This is still exercise 402, looking at measures of location or measures of center, which is mean, median, and mode. Now, you can find mean, median, mode using normal data, data in a table with dot plots, stem and leaf plots, etc. Sometimes they give you the cumulative frequency, not the ordinary frequency. Cumulative frequency is an accumulation. It's like a progressive total. It sounds like accumulate, doesn't it? Cumulative. So it is the accumulation or the progressive total of the frequency. See how the cumulative frequency here is 6. So let's just see what this is all about. The table shows the number of goals scored per game by Newcastle United Jets football team in the 2011-12 season. 0 goals scored per game was in 6 games. Now, 1 goal scored per game is not 17 games. That's the cumulative frequency. If you remember, I'm going to put an extra column in here. So I'm going to draw up a table here. If that's cumulative frequency, I'm going to stick in the frequency column. So, yes, there were 6 games in which no goals were scored, but you have to go 6 plus what gives me 17? 6 plus 11. So cumulative frequency, the way cumulative frequency is done, it is an adding or running total. This is a running total of the frequency. Now, always cumulative frequency has the same first value as the frequency column. So, in 6 games, no goals were scored. This takes me up to 17. So for 0 goals scored and 1 goal scored, the cumulative frequency is now 17. 6 plus 11 gives me 17. So in 11 games, 1 goal was scored. 17 plus what gives me 20? 3. See, what this cumulative frequency does is give me a running total of how many frequencies so far. 6 frequencies so far, 6 plus 11, 17 frequencies so far, 20 frequencies so far. Do you get it? Why do we do cumulative frequency? Why is it there? It helps you to work out the median. You know how it actually will tell you which scores you're sort of looking for. So it helps you work out where the middle score is. So how many, 3 goals in how many games? 4. 20. What about 4 goals? How many games? 0. And 24 plus 1. So in 1 game, 5 goals were scored. In 0 games, 4 goals were scored. So it says how many games were played. You can either add up all the frequencies, that's sigma f, or it's this bottom number here in the cumulative frequency total in column that tells me how many games were played. So 25 games were played. So that is also the beauty of a cumulative frequency column. It adds up all the frequencies for you, and the last number in the cumulative frequency column is the total games, the total number of scores. Like, I could start writing this data out. Look, 0 goals in 6 games. This is what this table means. 1 goal, 11 times, right? I don't know what I'm up to. 1, 2, 3, 4, 5, 8, 9, 10, 11. 2 goals, 3 times. 3 goals, 4 times, right? And 5 goals once. That's the actual data written out. I hope I didn't make a mistake. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4 of those, no 4s and 1 5. That's the actual raw data put into that table. If I added these all up, there would be 25 scores. You don't have to write this out, but this is, if you get stuck on a frequency table or something like that, you've got to think this is really what the data is. I've got 6 zeros, 11 ones, 3 2s. That's what it is. All scored per game is my X. This is my frequency column, and this is my cumulative frequency column. So if my cumulative, like, I'm going to show you cumulative frequency graph down here in a minute. This is a cumulative frequency graph. All right, one sec. Look at the first row here. Let's pretend the frequency is not there. I can cover it up. All right, I can cover it up. What it means is, at the end, if I wrote all these numbers out, at the end of the zeros, I have 6 frequencies. 6 scores so far. So 1, 2, 3, 4, 5, 6. Right? This is what it's telling me. By the time all the zeros and ones are are written out, I've got 17 numbers in total. So at the end of the ones, I've got 17 numbers, all together, which means I have to have how many ones? 11. See, at the end of the ones, I've got 17 numbers written out. There's just one sec. This again, at the end of the twos, once all the zeros, ones and twos are written out, I've got 20 numbers written up all together, which means I must have 3 twos. Does this make sense? At the end of writing all the threes, I've got 24 numbers written up, so I have to have 4 threes. Yeah? At the end of writing up all the fours, I've still only got 24 numbers written up, so I must have had no fours. And at the end of writing up all the 0, 1, 2, 3, 4, 5s, I've got 25 numbers in total. I must only have 1 5. So the way you do it, the way it works, is if I was given this data first, I go 6 numbers so far. 6 plus 11 is 17. 17 plus 3 is 20. 20 plus 4 is 24. 24 plus 0 is 24. 24 plus 1 is 25. So cumulative frequency tells you how many frequencies, how many numbers do I have so far. All right? And you have to work out the frequency column by subtracting. By working out, well, how did I get that? 6 plus what is that? You get it? Okay, now, how many games were played? 25 scores so far, so there were 25 games played. In how many games did the Newcastle United Jets score 2 goals? We've worked it out already. It's not 20 games, it's, what's the frequency for 2 goals? Because we're playing soccer here. This team played 25 games of soccer. In 6 games, they scored nothing. In 11 games, they scored 1 goal. Do you get it? Can you get that idea? In 3 games, they scored 2 goals. Do we know why it's 3 here? Because 17 plus 3 gives me 20. So in how many games did they score 2 goals? It's 3 games. The next one, what is the median number of goals? Now, this is the beauty of a cumulative frequency column. We know that there's 25 scores. So, C, the median. I've got 25 games or scores. Okay, it's not even. If I had 25 people, I can't halve 25, but I can halve 24. I would put 12 scores there, 12 there, and I would have 1 score sitting on its own in the middle. Or if I had 25 people lined up, because it's an odd number, you can pick the middle. Now, if you've got 12 scores here, 12 scores there, and 1 score in the middle, this is the 13th score. Do you get that? That the median is the 13th score. Yeah. Does that make sense? Yes. Look, some people like to use the formula, which is 25 plus, you go number of scores plus 1 divide by 2. I like to do this. Like what I would do, for example, and I'll just show it to you on a smaller scale. If I had 5 scores, I can't halve that. I'd put 2 there, 2 there. This 1 score in the middle is my middle score. Does that make sense? You know how you're crossing off 2 numbers off each side? You'll have 1 left in the middle. If I have 9 scores, that's odd. I can't halve 9, but I can halve 8. What's half of 8? I would put, if you had 9 numbers, you could cross off 4 from either side, from the beginning and the end. Wouldn't you have 1 number left in the middle? So if you've got an odd number of scores, it's really easy to find the median. It's the middle score. But if you've got an even number of scores, you can't pick out the middle number. You have to average the 2 middle numbers, which is what we were doing yesterday. All right? So I have to look for the 13th score. So the median is the 13th score, but that's not the answer. Now, you could look at this and pick me the 13th, or the idea is not to write this out. What if you had 200 numbers? You're not going to write them out. So tell me, all up to the 6th number, they're all zeros, and up to the 17th number, they're all ones up from the 6th to the 17th number. Isn't your 12th, 13th score somewhere in here? Do you get that? So which is 1. The 13th score has to be 1. If I counted 13 numbers, I'd get 1. Or if I look at the table, up to the first 6 scores, we've got zeros. And then from the 7th to the 17th score, they're all 1s. So the 13th score is definitely a 1. Okay, next, calculate the mean number of goals. Now, is X bar, the formula if you've got a table, is sigma fx over sigma f. Now, the thing is, I don't have an fx column. We did yesterday, but there isn't one here. So we're going to have to create it. All right, so it's just a quick way. Sigma fx is just a quick way of adding up all the goals that were scored. We want the mean number of goals scored. So can I go up now? So I'm going to have to create an fx column. So in 6 games, no goals were scored. 6 times 0, that's no goals. In 11 games, 1 goal was scored. 11 times 1 is 11. You know what I'm just doing? I'm adding up what all the zeros add up to. I'm adding up what all the 1s add up to. What do you think all the 2s add up to?
6.
Isn't it just 2 times 3? F times x. Your score is always x. Your frequency is f. F times x means multiply f by x. So my 2 times 3, my 2s add up to 6. You can tell me what my 3s add up to. 12. It's 3 times 4 is 12. What do my 4s add up to? Because there are none. And 5 times 1 is 5. So if I add up these, that would be sigma fx, the sum of the fx's. Now, adding them up, I can see, and I might just show the working. I've got 17 and 29, 34, I think. 34. So they add up to 34. 34 over, how many, what do the frequencies add up to? 25. The frequencies add up to 25. The frequency sum is always the same as the last number in cumulative frequency.
1.36.
And we get 1.36. Now, let's just have a look at this particular question. Remember, we're doing measures of location or center. Triple M, mean, median, mode. What's the median? What's the median? What's the mean? 1.36. What's the mode? What is the mode? Let's do the mode while we're here. Yeah, the score that with the highest frequency, or the score that occurs the most. It's the score that occurs the most. That's the mode. Score that occurs the most. Or you could say the score with the highest frequency, which is 1. Your mode is 1. Okay, so there are your 3 measures of location. Gives you the center. Whereabouts is the center of this data? All right. Question 12. This is not a cumulative frequency table. It's a cumulative frequency graph. The first hint of it is that it's going up. The second, please always read your axes, cumulative frequency. So you don't know what the frequencies are for any of these except for the first one. So I'm going to just remember this could be represented in a little table. I am going to draw a little table. Your scores are 15 to 19. That's your scores. You know, if they ask us for the mean, and they're not, we're lucky. These are your ages of people. You don't have frequency, by the way. You don't have it. You've got cumulative frequency. Cumulative frequency. You've got cumulative frequency. What's the cumulative frequency first? Read. Go. So then 20 to 24. What's the cumulative frequency?
15.
I think it's 7. No, it's bigger than 15. I think it's 17. It's less than halfway. I'd say it's 17. 25 to 29. I'd say my cumulative frequency is now 30 to 34. The reason I'm doing this is that we're going to 30 to 34. What is it? I think it's one less than 40. 39. 35 to 39. I think that looks like 45 to me. And the last one looks like 50. Now, 40 to 49. That's bad. Right, yes. Very good observation, everyone. They're not meant to do this. They are not meant to go up, 19 minus 15 is 4. 20 minus 20 is 4. The difference there is 4. But even though 15 to 19 if you subtract the numbers, it's 4. You've actually got 5 pieces of data in there. If you count on your fingers, 15, 16, 17, 18, 19. There are 5 scores in here. 20, 21, 22, 23, 24, 5 scores in there. This one happens to have 10. So it's either a misprint, and that should be 40 to 44. All right? But you are not meant to go and do that in a table or a graph. So I'd say this could be a misprint, and that should be 40 to 45. Mathematically, you would never do that. Have bits that fit 5 pieces of data, and this one's got 10 bits of data in it. All your columns are supposed to be the same, holding the same quantity of scores in a way. Do you know what I mean? Same with your row in the table. I'd say this is a misprint. I'm going 40 to 44. Okay? Which is why you wouldn't be able to do the mean here as well. So let's have a look. So this is cumulative frequency. Now that you know cumulative frequency, do you think you can work out frequency for me? Yeah. Do you know what happens on the first row? So far, I've got 5 frequencies. What's the first one? 5. So far, I've got 17 frequencies. What's my frequency for this one? 12. All right. So look, there is another way we can do it. I'm going to draw it here, but then I'm going to show you how to interpret it. Like in an exam, you don't have time to draw out the table. I'm doing this so that you can realize that this is what the data is, but we're going to learn to look at it in the graph soon, all right? But I need to show you this way first. Once you know this is the case, you can read the graph without drawing the table. 17 and 13 makes 30, all good. 30 and 9 makes 39. This one would be 6, and the next one's 5. So, you know what these numbers here are? We're going to look at the graph now. It's the gaps between each column. Look at 15 to 19, it's 5 high, all good. You know the gap, you know 20 to 24 shows those 5 frequencies plus the extra 12. That's why it's 17 high. The difference, you know this distance here is actually 12. You see where that's come from? Because you've got your 5 plus 12 gives 17. Can you see? This distance here, if that's 30 and that's 17, this distance is 13. Can you see that? Yes. Those are the numbers in the table. So if you're ever given the information in the graph, you don't need to do the table. You just need to say, yep, I've got an extra 12. I've got an extra 13. What's this one? That's 9. This is 6. And that's 5. They're the extras. They actually are the frequencies in my table. So, in an exam situation, you probably haven't got time to draw this table up, but you could put those numbers in. All right? But that is where they're coming from. You've got all your frequencies so far plus the extras. All my frequencies so far plus the extras. Do you get it? Yeah. Right, let's keep going. So, we're not going to look at the table anymore. We're going to look at the graph, because that's what you're supposed to do in this sort of question. The ages of people attending Keep Fit from 6 to 8 in the morning are in this cumulative. So, cumulative frequency. You know, before you start your question, highlight these things, circle these things. This is not ordinary frequency, and always cumulative frequency goes up. Doesn't go up and down like a normal frequency graph. Okay. How many people went to the centre from 6 a.m.? How many people altogether? You don't have to add them all up. You can see it here. It's the total. The total of all the frequencies is? Anyone? 50. So, A, 50 people in total went to the centre. B, how many people aged 30 to 34 attended the centre? 30 to 34, what is the increase from the column before? It's not 6, it's 9. You had whatever you had before plus the 9 extra. So 9 people aged 30 to 34 attended the centre. The median age, now this is the beauty of the cumulative frequency graph. Actually, we're going to use this using the graph. See, when you're given the table and you want to work out the median, you work out where the median is, this score, and you see which row it fits in. When we've got the graph, you're going to see which column it sort of fits in. But see this data here? This data is, it's like it's continuous data, like it's, you've got intervals. This is not a single score here. So what we've got to do with the cumulative frequency graph, I have to draw in the cumulative frequency polygon. Yeah. So I have to start from the beginning of the first column to the end of the first column and draw a line. And then from this corner to that corner, you do not join the top centers. Do you know when you do join the top centers? For what type of histogram? For a normal frequency. When it's cumulative frequency, you start from the beginning and join the top right corners. You know why? Because the frequencies are all up to the end of that number. If it's a normal frequency polygon, you join the centers. Do you remember that? So for cumulative frequency, you join the corners. Now, all you do for this type, it's quite different to doing it from the table. I know I've got 50 scores. So the median. So the median, so we join the top corners. Start from the beginning, join the top corners of each column. So the median is at 50%. You just go 50% or half of 50. That's a half of 50 is what? Median is at the middle. It's not sort of, I don't have to average two numbers for this when you're reading it off the graph. Median is the halfway mark, isn't it? So I go 50% of 50. It's the halfway mark up here. A half of 50 is 25. So you come across with your pen on the graph at 25, exactly at 25. Can I move? So you come across your graph at 25 with a dotted line, and you hit the column and you come down. Now, this line comes down somewhere in the group of 25 to 29. So that's called a class. So I could say the median class is 25 to 29, or the median is approximately, you've got to say if this is from 25 to 29, wouldn't you say it's around 20, I think it's close to 28, about 27, 28, 27 and a half, 28 approximately. All right. Look, it's more than halfway, isn't it? So halfway would be probably 27. So it's a bit more than 27. It's about 27 and a half, 28. Or the median is approximately 27.5 through to 28. All right? Do you get, I'm sort of approximating where it would be roughly. If that represented 25 and this represented 29. I think it's around 27 and a half, 28. Okay, so you will see both answers like that. Depends if they say approximate the median, you've got to come down and approximate roughly on that scale where it would fall. And are we okay with that? Or I could say the median class. It's that age group. The median is the 25 to 29 age group, or approximately 27 and a half to 28. See, when you see the data, you have no idea, when you look at that, how many people were 25 or how many were 29. They could all be 29 for all you know. There were 13 people in that age group, but you have no idea how old each individual person was. So when we're grouping data like this, you don't know the individual data scores. Do you understand? You just know that there were 13 people in that age group. All right? It means that if we do come to work out the mean by using the class center like we did yesterday, it's just an estimate. It will never be exact. So the only way you could work out exact mean is here, because I know I've definitely got 6 goals, 6 games with no goals, 11 games with 1. But whenever you've got grouped data like this, the mean is never exact. Because you're just, I would use the class center. So if I did want to find the mean here, I think we did it yesterday. I can do it now for extra practice. No, we probably should. So let's just do the modal age of people attending. The modal age of people attending. If you were looking at the graph, isn't this your biggest jump? Yeah, but that's not the modal age. The modal age is the 25 to 29 age group. The score that occurs the most. So the modal age, you can't say it's 27. It is the 25 to 29 age group. Or it's called the modal class. Okay? You know how we have something called class center? Because we call that age a class. That's a class, 15 to 19. They call them class. So if you did have to work out the mean, if you were asked to work out the approximate, and it would only be an approximate mean, right? If you were asked to do that, you would have to do the class center. So where's that? I'm going to do it here. So if I want to work out the approximate mean, I would have to use class centers. Because I'll look at the 15 to 19 age group and I say, which number do I use? I don't know. So if you wrote out the numbers 15, 16, 17, 18, 19, could you pick out the middle number? What is it? There's 5 numbers. Or you add them together and divide it by 2. What's 15 plus 19? Class centers. 15 plus 19 is 34 divided by 2, it's 17. What's 20 plus 24? 44 divided by 2 is 22. Look at the pattern. 15 to 19, 25 to 29. What's the class center? 27, 32, 37. Can you see why I changed this last one? Well, I'm hoping it was a typo in the book. 42. If you had to, so I've done this in red. This is an extra part of the question. If you had to work out, so your class center is called your new X, class center, CC. If you have to work out mean, do you know the formula for mean? What's the formula for mean? Guys, you've got to know this one. Sigma, mean is sigma fx over sigma f. That's the formula for mean. You need to know it. All right, what's f times x? I know what f is. What's x? I don't know which one of these is. That's why we use the center. So 5 times 17. Okay? The f times the x. 5 times 17 is, etc. And we keep going. 22 times 12. 220 and 44. 264. Anyone? Did you do 22 times 12? Guys, can you work them out? I'll do this one. That's 210. That's 180 minus 18. Is that 162? Please check them. I'm doing them in my head. 320. Is it 288? Come on. What's 27 times 13? 300 and what? Yep, next one. It's 32 times 9. 2. Just check the next one. 37 times 6. 6 is, yeah? 4 6s, yeah. 222. And hopefully the last one's 210. So look, they didn't ask you to do the mean, but this would be the worst type of question you could get to work out this mean. 225. No. 42 times 5. 42 times 5. I think it's 210. So if you want to work out the mean, you would add up all those fx's and you would divide by what? What's the sum of your frequencies? How many frequencies are there? There are 50. It's the bottom of the CF graph. Like it's the top of the CF graph or the bottom of the CF column. There are 50 scores. So you'd add up all of those and divide by 50. And we're hoping it would, now listen, your number's got to be probably around that 25 to 29 markers as well. But this is an approximation. It is not an exact mean. Anyone add up all those? I think it's 1,000 and something. Right, see how it's sort of, remember, you've got to keep it in the context of the question, the average age of people going to this gym. Like the median was in the 25 to 29 age group. The mode is in the 25 to 29 age group. The mean is 28.8. All right, I know they didn't ask for that, but I thought we would do it anyway.